Okay, today we're going to be covering just 14.1 and 14.2, essentially the front side of your note sheet. We'll cover the back side of your note sheet in a separate video. Alright, so 14.1 covers the Earth's atmosphere. We're just going to talk about the things that are actually made up, or what's in the Earth's atmosphere. We'll get to some of the layers and things later. Okay, the Earth's atmosphere is made up of layers of gas that help protect Earth from the sun's harmful radiation. Different layers do different things. We have the ozone layer that kind of keeps out ultraviolet radiation, or at least a lot of it. So everything has its job up there. In the atmosphere itself, though, you have to realize that it's not just gas. It's primarily a gas atmosphere, we know. But it also contains solids. There's lots of dust and smoke particles that float around in the Earth's atmosphere. There's also liquid water in the atmosphere. If we get enough liquid water in the atmosphere, we get a cloudy day. The Earth's atmosphere is made up of, actually, the highest percentage of gas in the atmosphere is nitrogen. Nitrogen composes about 78% of the atmosphere. Most people, you could probably ask them, they would tell you that oxygen would make up the highest percentage of gases, but it's not even close. Oxygen only makes up 21% of the Earth's atmosphere. And then these gases here, the argon, carbon dioxide, carbon monoxide, those gases as a general group make up 1% of the atmosphere. And are grouped together, we actually call those greenhouse gases. Okay, the greenhouse effect is a very positive thing. It keeps our Earth warm. It traps in just the right amount of heat and lets out just the right amount of heat. The greenhouse gases that we're talking about are obviously the ones that concern people because they are increasing. We are continually pumping more carbon dioxide and carbon monoxide and methane into the atmosphere. And what those gases do is they absorb heat, therefore letting less of the sun's radiation back out into the atmosphere, or into space, and absorbing more. And the more more heat that gets absorbed by those greenhouse gases, the warmer our planet becomes. Venus is an example of an atmosphere that has way too much greenhouse gas and therefore traps in all of the heat in the atmosphere, and the temperatures there are, in the areas of about 800 degrees. So it's just crazy warm on Venus because it doesn't let any of its heat back out into space. Okay. Purpose of our atmosphere I've touched on just briefly. The purpose is to support life on Earth, of course. It provides us oxygen. It provides us water. It keeps the temperatures at a moderate range. And of course, it's also where the weather occurs. Weather is really just the atmosphere's attempt to maintain balance. If it has too much heat, too much moisture, things of that nature, it's going to storm, it's going to rain, we might have severe weather, but that's just atmosphere just trying to balance out the energy, the temperature, everything in its atmosphere just to maintain balance. Okay? Alright, so the trends, these are just a couple of generalizations here. As air pressure in the atmosphere is going to decrease as the altitude increases. Okay, so if you go higher up in the atmosphere, okay, you go up on, you're up to Colorado, you're up in Denver, you're now a mile high, you go up on Pikes Peak, you're up at about 14,000 feet. The higher you go in the atmosphere, the air pressure will decrease. So people will say a phrase of you're in thin air, and that is actually true. There are less air molecules the higher up in the atmosphere you are. Okay, so the thickest part of the atmosphere would be at sea level, and then as you go on and on and on all the way up, the air gets thinner and thinner and thinner because there's less molecules. Now the temperature in the atmosphere doesn't quite work that way. You might suspect that the higher you get in the atmosphere, the colder it's going to get. It actually alternates with each layer. So the layer that we live in does get colder as the altitude increases. However, when you get to the next layer in the atmosphere, the stratosphere, the temperatures actually increase as you move up. So those alternate, and we'll get to that in later sections and explain why that is. All right, so 14.2, energy from the sun. Okay, the sun provides almost all of the energy to the earth in the form of either visible light, or what we're talking about now is more the infrared heating of the surface. Okay, and we learned at the beginning of the year that areas that receive direct sunlight are going to be your warmer climates. So near to the equator is going to get hit more directly by the sun's light, and as you move towards the poles, you're going to be hit more indirectly by the sun. Therefore, you're going to have a colder climate. Okay? Now, sun heats the earth through what is called the greenhouse effect. Okay, this picture kind of demonstrates or shows you the incoming solar energy, okay, some of which is reflected back out before it ever gets to the surface. So you have some that's reflected by the atmosphere, some is reflected by the clouds, and some of it simply just bounces right back up off of the surface. Okay, some of which, of course, does get absorbed. Okay, and that's what actually heats the air. There's a misconception that the sun heats the air. The sun does not actually heat the air. Solar radiation, as we're talking about right here, solar radiation only heats the surface of the earth. Okay? Now, radiation is energy that is transferred in the form of waves or rays. Okay? The best way to describe radiation is just to experience it. So if you were to stand near a campfire, if you were to stand near a stove or some sort of a heat source, you will feel the heat kind of soaking into your body, but only to the surface that is facing the heat source. Okay, so if you were to stand outside and it was cold out and you were to stand near a campfire for, let's say, 15 to 20 minutes, and you felt the front of your body would feel very warm. If, however, you felt the back of your body, it would still feel very cold because the air behind you is obviously still going to be cold, because that campfire is not heating the air, it is heating solid surfaces like your body. Okay? Now, so what the sun does then is it soaks into the earth here, warms up the ground. Okay? Then we have conduction. Now, conduction is the flow of heat energy through an object that has direct contact with a heat source. So now we're talking about actually touching a warm surface. All right? So now we have these air molecules down here that are actually touching the warm ground. Okay, so those air molecules, the heat is going to transfer from the ground to those air molecules, making those air molecules very warm. Okay, then the third thing that's going to happen is through the process of convection, which is the transfer of heat by flowing materials. The hot air rises, cold air sinks concept. So now we're getting into density. Okay, so let's go through the process. The sun, radiation, heats the surface of the earth, whether that be water or land. Okay? Then through conduction, the air molecules that touch the Earth's surface are warmed through conduction. Those air molecules then, being the warmest and the least dense, will rise. And these air molecules up here, being the coldest and most dense, will sink through the process of convection. They then, of course, will touch the Earth's surface, rise back up, sink, and then we get that nice convection cycle occurring through hot air rising and cold air sinking. Okay, so that gets us to the end of the first page. You should have that part of your sheet entirely filled out. If not, go back through the sheet, go back through the video, and find the parts that you are missing.